March 26th, 1945. The streets of Oberembt, Germany echoed with the clang of tracks on cobblestone. Inside a captured German assault gun, American ordnance officers stared at the weapon system before them, with expressions caught between awe and disbelief. The 380mm rocket launcher dominated the fighting compartment like some industrial monument to desperation. One engineer lifted a massive rocket projectile, nearly 5 feet long, weighing over 700 pounds. His hands traced the fins, the motor housing, the explosive warhead designed to punch through concrete fortifications. Then he asked the question that would define the evaluation. How many rounds can this thing actually carry? A German prisoner, still wearing his dust-covered tanker uniform, answered through an interpreter. 14. Total. The officer blinked. 14 rounds. In the entire vehicle? The prisoner nodded. 1 in the barrel, 1 on the loading tray. 12. More in storage racks. That's everything. The American engineers exchanged glances. This was the Sturmtiger, Germany's answer to urban warfare, a weapon so massive it required a Tiger tank chassis just to move, and it could only fire 14 times before running completely dry. The laughter started quietly, then spread, because in a war where American factories were producing thousands of shells per hour, where supply trucks delivered ammunition by the ton, the idea of a 65-ton assault gun with barely enough rounds to fight for 20 minutes felt less like engineering and more like comedy. But the laughter would fade when they discovered the truth behind those 14 rounds. A story of industrial collapse, impossible dreams, and the moment Germany's war machine finally admitted it could no longer sustain the fight. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Winter, 1942, Stalingrad. The name itself became a graveyard. German soldiers fought street by street, building by building, room by room. Every corner hid Soviet defenders. Every cellar became a fortress, every apartment block a killing ground. Traditional tanks, designed for open battlefields and sweeping maneuvers, found themselves trapped in narrow streets where their long guns couldn't depress enough to hit targets 10 meters away. Infantry advanced into courtyards and were shredded by machine gun nests firing from second-story windows. The Wehrmacht possessed assault guns like the Sturminfanteriegeschütz 33B, mounting a 15-centimeter howitzer on a Sturmgeschütz 3 chassis. These vehicles could demolish walls and suppress defenders, but their armor, adequate for the plains of France, proved woefully insufficient against Soviet anti-tank rifles and close-range ambushes. 12 were lost at Stalingrad, knocked out, abandoned, or burned to husks in the rubble. The survivors limped home carrying reports that painted a grim picture. Urban warfare demanded something new, something heavier, something capable of reducing an entire building with a single shot. By autumn 1943, German engineers gathered in conference rooms where maps of Stalingrad still hung on walls like cautionary tales. The Brummbär, the Sturmpanzer IV, was already in production. It mounted the same 15-centimeter gun on a Panzer IV chassis with improved armor. Better than its predecessor, certainly. But infantry anti-tank weapons were evolving faster than German armor could keep pace. Panzerfausts, bazookas, and handheld rockets turned every alleyway into an ambush site. The infantry needed more than a bigger gun. They needed a weapon so devastating it could destroy fortified positions before defenders could react. A weapon wrapped in armor so thick it could withstand anything short of direct artillery hits. The question was, what kind of gun could deliver such power? The initial proposal called for a 210mm howitzer, massive by any standard. But manufacturing delays plagued the project. The weapon simply wasn't available. Then someone from the Kriegsmarine, Germany's navy, suggested an alternative. The 38-centimeter Raketenwerfer 61, originally designed as a depth-charge launcher to attack submarines from coastal positions. It fired rocket-propelled projectiles nearly 1.5 meters long. Each warhead contained 125 kilograms of high explosive, enough to obliterate bunkers, enough to collapse reinforced concrete, enough to turn entire city blocks into rubble. The rocket motor continued burning after the projectile left the barrel, meaning it didn't need a long gun tube to achieve range. A short barrel, just 2 meters long, could fire these devastating rounds up to 6,000 meters. It was unconventional. It was radical. It was exactly what Stalingrad had demanded. But mounting such a weapon on a vehicle posed challenges that would test Germany's engineering to its limits. By September 1943, plans solidified. Krupp would fabricate new Tiger I armoured hulls specifically for this project. Henschel would handle chassis assembly. Alket, the Altmärkische Kettenfabrik company in Berlin, would mount the superstructures and install the rocket launchers. The Tiger I chassis was chosen for practical reasons. It was already in production. Its suspension could handle the weight. Its drivetrain was proven. And critically, using an existing chassis meant sharing spare parts and avoiding the nightmare of creating an entirely new vehicle from scratch. The Tiger's frontal armour, already formidable, would be reinforced. The original turret would be removed entirely. In its place, a fixed casemate-style fighting compartment would be welded to the hull. Thick steel plates angled at 47 degrees from vertical, 150 millimeters thick at the front, 82 millimeters on the sides and rear. Enough protection to absorb punishment that would cripple lesser vehicles. The superstructure had to be specially reinforced with massive welds and oversized bolts, because when the rocket launcher fired, the recoil was violent enough to tear weaker structures apart. The weapon itself presented unique engineering problems. Rocket motors produced tremendous heat and pressure. The exhaust couldn't be vented into the fighting compartment without killing the crew. But if the gases weren't vented at all, the pressure would rupture the barrel. The solution was a ring of ventilation shafts wrapped around the muzzle, 30 to 31 small tubes, depending on the production batch, that gave the weapon its distinctive pepperbox appearance. When the rocket fired, exhaust screamed through these vents in a shower of flame and smoke. Spectacular, terrifying, and brutally effective at clearing the barrel. On October 20th, 1943, the prototype was ready. It rolled onto the training grounds at Aris, East Prussia, where Adolf Hitler himself waited to inspect it. The vehicle was imposing, shorter than a standard Tiger tank, just 6.28 meters long compared to the Tiger's 8.45 meters. But what it lacked in length it made up for in sheer presence. The massive rocket launcher dominated the front. The thick armor plates gleamed under inspection lights. The steel road wheels, now rimmed with metal instead of rubber to support the added weight, clanked heavily on the concrete. Hitler circled the machine slowly. His hands traced the armor. His eyes studied the ventilation shafts. Engineers explained the loading mechanism. The crane mounted at the rear to lift projectiles into the vehicle. The loading tray with rollers to move rounds into the breech. The storage racks that would hold 12 additional rockets inside the cramped fighting compartment. Hitler's vision for the weapon was grand. He imagined companies of Sturmtigers, 14 vehicles strong, attached to divisions storming Soviet cities. He calculated that each vehicle would burn through 300 rounds of ammunition per month, a staggering figure, an optimistic figure, a figure that assumed Germany's industrial capacity could keep pace with Hitler's imagination. The prototype passed its trials. The weapon fired successfully. The armor held. The suspension managed the weight. Hitler approved production on the spot. But the order came with a caveat. Germany couldn't afford to interrupt Tiger I production. The war was consuming tanks faster than factories could build them. So instead of using new hulls, the Sturmtigers would be constructed from battle-damaged Tiger I's sent back for repair. Tanks with blown engines, shattered transmissions, or damaged turrets. Hulls that would otherwise be scrapped could be rebuilt into assault guns. Resourceful, efficient, and completely inadequate for the scale of production Hitler envisioned. The first 3 production models were completed by Alket in August 1944. 10 more followed in September. another 5 in December. 18 vehicles total. By the time the last Sturmtiger rolled off the production line, the war had already turned irrevocably against Germany. The weapon designed to conquer cities would instead be used to defend them, and the 14 rounds each vehicle carried would become not just a logistical footnote, but a symbol of Germany's collapsing industrial base. Inside each Sturmtiger, space was at a premium. The 5-man crew, driver, commander, gunner, and 2 loaders, worked in a compartment dominated by rocket projectiles. Each round was enormous, 1.5 meters long, 345 kilograms of high-explosive warhead, rocket motor, and stabilizing fins, far too heavy to be lifted manually. The loading process required the entire crew. First, the commander would open the large rectangular hatch in the roof. Then the crane, mounted at the rear of the superstructure, would swing into position. One loader operated the hand-cranked winch, carefully lowering the hook through the hatch. Another loader outside guided the projectile from the external ammunition carrier, a separate vehicle that was supposed to accompany each Sturmtiger. Only one such carrier was ever completed. Once the rocket was hooked, the crew winched it up, rotated it through the hatch, and lowered it into the fighting compartment. From there, the loaders wrestled it onto the loading tray, a roller-equipped platform that guided the massive projectile toward the breach. The entire process took time. Estimates varied, but experienced crews could reload in roughly 40 seconds once the round was inside the vehicle. However, the full cycle, including crane setup, positioning, and transferring ammunition from an external source, took anywhere from 10 to 15 minutes per round. To fully reload all 14 rockets would consume over 2 hours, assuming the crew had access to spare ammunition, assuming the vehicle wasn't under fire. Assuming the external carrier was still functional, the 14 rounds were divided carefully, one projectile already loaded in the breech, ready to fire immediately. One round on the loading tray, positioned for quick reloading. 6 rounds stored on the left side of the fighting compartment in a vertical rack, 6 more on the right side. The racks were bolted to the superstructure walls, each cradle padded to prevent the rockets from shifting during movement. Despite the tight quarters, the arrangement was methodical. German engineers had calculated the exact spacing needed to allow loaders to maneuver without colliding in the darkness. 2 types of ammunition were available. The Raketensprengranate 4581 high-explosive round, designed for mass targets, bunkers, troop, concentrations, building complexes. Its 125-kilogram warhead created a danger zone extending 500 meters from the impact point. Fragments from the blast could wound or kill infantrymen nearly a quarter-mile away. The second type, the Raketen Hollandongranit 4592, carried a shaped charge warhead. This round was specifically engineered to penetrate reinforced concrete, up to 2.5 meters deep, enough to breach the thickest bunker walls, enough to collapse underground fortifications, enough to punch through any defensive structure the Red Army or Western Allies could construct. Both projectiles used the same rocket motor, a propellant charge weighing 40 kilograms that ignited after the round left the barrel, accelerating the projectile from 45 meters per second to 250 meters per second. The range reached 5,500 to 6,000 meters, depending on the angle and conditions. For a weapon this size, that was acceptable. For a weapon this heavy, carried by a vehicle this slow, it was the best engineers could achieve. But there was a problem that would become catastrophic. Germany's industrial capacity was crumbling. By August 1944, when the first production Sturmtigers entered service, Allied bombing campaigns had devastated German factories. Rail lines were cut, supply chains fractured, raw materials became scarce. Steel production dropped, copper vanished, rubber disappeared entirely. The Alket factory in Berlin managed to complete 18 Sturmtigers by December 1944, 18 vehicles. Hitler had wanted companies of 14 each. He had imagined divisions supported by these assault guns laying waste to enemy positions. Instead, Germany fielded barely enough to equip 3 platoons. Worse still was the ammunition situation. Hitler believed production would reach 300 rounds per month, enough to sustain aggressive operations, enough to allow Sturmtigers to bombard cities until resistance collapsed. The reality was starkly different. By the time production ended, only 317 rockets had been delivered to German forces, 317 rounds, total, for 18 vehicles, each carrying 14 projectiles. That meant Germany had produced barely enough ammunition to load each Sturmtiger once, with a handful of spare rounds left over. If every vehicle fired its entire internal supply just once, the entire stockpile would be exhausted. There would be no resupply, no ammunition convoys delivering fresh projectiles, no reserve depots stocked with thousands of rounds waiting for requisition. 317 rockets. That was the sum total of Germany's investment in Sturmtiger firepower. And with that, the myth of the invincible assault gun began to crack. Because no matter how thick the armor, no matter how devastating the warhead, no matter how skilled, the crew, a weapon with no ammunition is just 65 tons of steel, slowly rusting into irrelevance. The first Sturmtigers entered combat in August 1944 during the Warsaw Uprising. Polish resistance fighters of the Home Army had risen against German occupation, seizing control of large sections of the city. Street fighting erupted across entire neighborhoods. Barricades appeared at intersections. Buildings became fortresses. Sewers turned into supply tunnels. It was the exact scenario the Sturmtiger had been designed for. The prototype vehicle, still fitted with mild steel armor, was rushed to Warsaw alongside 2 production models. Workshop personnel who had helped build the machines now crewed them. They advanced through rubble-choked streets, turrets traversing slowly, searching for targets. When the first rocket fired, the effect was immediate and horrifying. The projectile arced through the air, trailing smoke and flame. It struck a 4-story apartment block, occupied by resistance fighters. The building didn't just collapse, it disintegrated. Walls blew outward. The roof caved inward. Dust clouds erupted from every window. When the smoke cleared, nothing remained but a crater filled with shattered bricks and twisted steel. Resistance fighters watching from nearby positions felt the shockwave ripple through their bodies. One later wrote in his diary, "We thought the Germans had brought some new kind of artillery. We didn't realize it was a single tank." The Sturmtigers fired again and again. Each shot obliterated another strongpoint. Each explosion sent defenders scrambling for cover, but after a handful of engagements, the vehicles withdrew. Not because they had been damaged, not because resistance fire had driven them off. They withdrew because they had expended their ammunition, 14 rounds per vehicle. Some missions burned through the entire load in a single afternoon. Resupply took days, sometimes weeks. And each time a Sturmtiger fired, the available ammunition pool shrank. 3 companies were eventually formed: Panzer Sturmkompanien 1000, 1001, and 1002. Each company was supposed to field 14 vehicles. That figure was quietly reduced to 4 vehicles per company. 2 platoons of 2 Sturmtigers each. Even that modest goal proved impossible. By the time the Battle of the Bulge began in December 1944, only 7 Sturmtigers participated. 7 vehicles. For an offensive involving hundreds of thousands of German troops, Companies 1000 and 1001 were attached to the 6th Panzer Army and thrown into the Ardennes, fighting around Düren and Euskirchen. One crew from Company 1001 claimed a remarkable success. They fired a 380mm rocket into a Belgian village where American Sherman tanks had gathered. The blast reportedly destroyed or disabled multiple Shermans, killing or wounding their crews. It was the only confirmed tank-on-tank engagement a Sturmtiger ever participated in, a single successful shot, against stationary targets, in a war that had already been decided. After the Ardennes offensive collapsed, The surviving Sturmtigers were pulled back across the Rhine. They dug into defensive positions between Bonn and Drollschegen. Crews were ordered to preserve ammunition. Fire only at critical targets. Make every shot count, because there were no more rockets coming. The ammunition stockpile was exhausted. What remained was scattered across depots and supply dumps, some of which had already been overrun by Allied advances. Crews began rationing their 14 rounds like water in a desert. By early 1945, the Sturmtigers had become more symbol than weapon, tanks so fearsome that their mere presence might deter attackers. But once the ammunition was gone, they were useless. Some were abandoned intact when their crews ran out of fuel. Others were destroyed by their own crews to prevent capture. A few fought until the last rocket was fired, then surrendered quietly, their mission complete, their war over. When American and British forces began capturing Sturmtigers in March and April 1945, ordnance teams scrambled to evaluate them. One vehicle was recovered by the 464th Ordnance Evacuation Company near Düren. It had been immobilized in a ditch during a retreat, hit at least 3 times by a Sherman tank from C Company, 743rd Tank Battalion. The 80mm thick rear armour had been penetrated. The crew bailed out, all surviving except one member who was shot by infantry as they fled. The captured Sturmtiger was shipped to Britain for evaluation. British engineers tested it extensively at Sennelager before sending it to the School of Tank Technology at Chertsey. They fired the rocket launcher, measured the blast, analysed the armour, documented every detail. Then they scrapped the vehicle. Only the massive 380mm rocket launcher survived, eventually ending up on display at the Tank Museum in Bovington. The Americans captured their own examples. One Sturmtiger was transported to the Aberdeen Proving Ground in Maryland. Engineers there subjected it to similar tests. They marvelled at the engineering, the thickness of the armour, the complexity of the ventilation system, the sheer audacity of mounting such a weapon on a tank chassis. But what fascinated them most was the ammunition situation. When interrogators questioned captured German crews, the answers were always the same. 14 rounds, total, no resupply. We fired until we ran out, then we waited, sometimes for days, once for 2 weeks. By then, the battle had moved on. American officers shook their heads in disbelief. They came from a military where ammunition flowed like rivers, where supply trucks delivered thousands of shells daily, where entire cargo, ships were loaded with nothing but ordnance bound for European ports. The idea that Germany had built an assault gun this powerful, this heavily armoured, this technologically sophisticated, and then equipped it with barely enough ammunition for a single engagement felt surreal. It wasn't a logistics problem, it was a strategic collapse. One engineer at Aberdeen famously quipped, "They built a 65-ton paperweight." The comment spread through the ordnance community. Soon, every American engineer evaluating captured German equipment had heard the story of the Sturmtiger, the mighty assault gun, the terror weapon, the building crusher. That could only carry 14 rounds. The laughter that had started in Oberembt echoed through Aberdeen, through British testing facilities, through French depots where captured vehicles were catalogued and studied. Not cruel laughter, not mocking laughter, but the laughter of men who finally understood just how desperate Germany's situation had become. This wasn't innovation, it was desperation wrapped in steel. And the 14 rounds told the entire story. By 1944, American industry had become a force of nature. Factories in Detroit, Pittsburgh, Cleveland, and dozens of smaller cities ran 24 hours a day, every day, producing everything the war demanded. Ammunition plants pressed out shells by the millions. Assembly lines stamped tank hulls faster than crews could be trained to drive them. Cargo ships crossed the Atlantic in convoys so large they stretched beyond the horizon. Everything was measured in production rates. Sherman tanks, 4,000 per month at peak production. Artillery shells, over 1 million rounds per week. Ammunition for individual weapons, billions of rounds annually. The logistics trains supporting this effort were marvels of organization. Supply depots in Britain held warehouses stacked floor to ceiling with crates, each crate labelled, each item catalogued. Need 5,000 rounds of 75mm ammunition. It would arrive by truck within hours. Need a replacement engine for a Sherman? A depot 40 miles back had 50 in stock. When American armor divisions pushed into Germany, their supply lines stretched hundreds of miles. But they never faltered. Engineers built temporary bridges across rivers in days. Trucks rolled forward day and night, headlights blazing, delivering fuel, food, and ammunition to the front. If a unit expended its ammunition during a battle, resupply arrived before the smoke cleared. Contrast that with Germany. By late 1944, the Luftwaffe had been swept from the skies. Allied bombers struck factories, rail yards, and supply depots with near impunity. Oil production collapsed. Fuel became so scarce that tanks were sometimes abandoned not because they were damaged, but because there was no gasoline to run them. Steel allocations were diverted to U-boats and defensive fortifications. Ammunition production slowed to a trickle. Priority went to weapons that could be mass-produced quickly: Panzerfausts, small arms cartridges, artillery shells for conventional guns. Specialized ammunition for vehicles like the Sturmtiger simply didn't make the cut. When Adolf Hitler ordered 300 rounds per month, planners nodded and drafted production schedules. But those schedules existed only on paper. The factories couldn't deliver. The raw materials weren't available. The workers were either conscripted into the military or killed in bombing raids. 317 rounds. That was all Germany managed to produce before the war ended. 18 Sturmtigers. 317 rockets. Less than 18 rounds per vehicle on average. American engineers doing the math couldn't believe it. Their own ammunition production was so vast that a single depot in France held more artillery shells than Germany had produced in the entire final year of the war. When ordnance officers examined captured Sturmtigers, they found ammunition racks designed to hold 12 rounds on each side. But many vehicles had empty racks. Some carried only the pre-loaded round and the one on the loading tray. 2 shots, then silence. Crews explained they had been issued minimal ammunition and told to preserve it for critical targets. Sometimes convoys promised resupply but never arrived. Sometimes depots were bombed before rockets could be distributed. Sometimes the ammunition existed, but there was no fuel to transport it. One captured commander admitted, "We spent more time hiding the vehicle than fighting. We had maybe 6 or 7 rounds total. Once those were gone, we became a pillbox. We couldn't move. We couldn't fight. We just waited for orders that never came." American engineers compiled their findings into reports that circulated through military intelligence channels. The documents described the Sturmtiger's capabilities in clinical detail: armor thickness, rocket, propellant composition, penetration values. But the sections on ammunition logistics read less like technical analysis and more like obituaries for German industrial power. The Sturmtiger wasn't a failure of engineering. It was a monument to strategic collapse. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. March 1945. The final battles for Germany had begun. Allied forces pushed from the west. Soviet armies rolled in from the east. Cities that had once seemed invincible now crumbled under relentless bombardment. In this chaos, the remaining Sturmtigers were scattered across defensive positions, dug into rubble, hidden in forests, waiting for targets that would justify expending their precious few remaining rounds. Near Remagen, where American forces had captured the Ludendorff Bridge intact, German High Command mobilized companies 1,000 and 1,000. 7 Sturmtigers total. Their mission was to destroy the bridge and cut off the American advance across the Rhine. Crews approached the river under cover of darkness, their massive vehicles grinding through bombed-out streets. Commanders studied the bridge through periscopes. Range was calculated, trajectories plotted. Then reality intervened. The Sturmtiger's 380mm rockets were devastating against buildings and fortifications. But they were not precision weapons. The short barrel and rocket propulsion made accuracy at long range unreliable. The bridge was a narrow target, a moving target, swaying slightly in the current. Crews fired. Rockets arced through the air. Some fell short, exploding in the river. Others overshot, detonating on the far bank. One hit a nearby building, bringing it down in a cloud of dust and debris. But the bridge stood, undamaged, defiant. After expending most of their ammunition, the Sturmtigers withdrew. The mission was a failure. Not because the crews lacked skill, not because the weapon lacked power, but because a tool designed to demolish static fortifications couldn't hit a target that required surgical precision. American forces reinforced the bridgehead. Engineers built pontoon bridges nearby. The Rhine crossing became unstoppable, and the Sturmtigers that had been intended to change the course of battle became footnotes. By April 1945, the remaining vehicles were scattered across Germany's shrinking territory. Some were dug into defensive positions around Paderborn, their hulls camouflaged with branches and rubble, waiting for American armor to appear. One Sturmtiger near Oberembt was abandoned after it became stuck in a ditch during retreat. The crew set demolition charges to destroy it, but the charges failed. American troops captured it intact, crew manuals still inside, ammunition racks empty. 3 final Sturmtigers from Company 1001 fought in the defense of Drollschegen east of Bonn. They expended their last rockets against advancing infantry and were destroyed by their own crews when resupply became impossible. Maintenance logs found in the wreckage showed the vehicles had been plagued by mechanical problems, broken tracks, failed engines, transmission issues. Without spare parts or time for repairs, even functional Sturmtigers became liabilities. When Soviet forces pushed into eastern Germany, they captured one Sturmtiger in the Elbe region, chassis number 205543. It was photographed, documented, and eventually transported to the Kubinka Tank Museum near Moscow, where it remains on display to this day. A second surviving example, chassis number 250174, was recovered by American forces and sent to Aberdeen Proving Ground. After extensive testing, it was loaned to various military institutions before ending up at the Deutsches Panzermuseum in Münster, Germany. Out of 18 Sturmtigers built, only 2 complete vehicles survive. Most were destroyed in combat, abandoned due to mechanical failure, or scrapped after the war. The third surviving example is not a complete vehicle, but the massive 380mm rocket launcher itself, preserved at the Tank Museum in Bovington. When American engineers published their final evaluations, the tone was almost sympathetic. They acknowledged the Sturmtiger's strengths. The armor was exceptional. The rocket launcher was genuinely impressive. The engineering solutions, like the ventilation shafts and crane loading mechanism, showed ingenuity. But every report circled back to the same conclusion. A weapon this specialized, this resource-intensive, required an industrial base capable of sustaining it. Germany no longer had that base. The Sturmtiger arrived too late, in too few numbers, with too little ammunition, to change anything. For German crews who had served in Sturmtigers, the experience left lasting impressions. Some spoke with pride about the weapon's destructive power. One former gunner recalled firing at a concrete bunker near Warsaw. The rocket hit dead center. The entire structure lifted off its foundation and collapsed inward like a house of cards. I've never seen anything like it. One shot. Total destruction. Others spoke with frustration. A driver from Company 1001 described the Battle of the Bulge. We advanced into position, fired our rounds, then waited and waited. Resupply never came. We sat there for 3 days, completely useless, while the battle moved on without us. It was humiliating. A commander from Company 1000 admitted that by March 1945, his crew had stopped believing in victory. We knew the war was lost. We knew our ammunition was gone. But orders were orders. We stayed with the vehicle until American tanks appeared. Then we surrendered. What else could we do? The ammunition shortage wasn't just a logistical problem. It was psychological. Crews climbed into their vehicles knowing they had perhaps a dozen shots, maybe fewer. Every engagement became a calculation. Is this target worth a round? Will we get resupply? What if we need the ammunition tomorrow? That kind of uncertainty eroded confidence. It turned aggressive crews into cautious ones. It transformed the Sturmtiger from an offensive weapon into a defensive last resort. Hitler's vision of companies burning through 300 rounds per month became a bitter joke. 300 rounds per month required 9 factories producing full-time. It required rail networks delivering projectiles to frontline depots. It required ammunition carriers accompanying every Sturmtiger, each loaded with spare rockets. Germany in 1944 couldn't manage any of those things. The 317 rounds that were produced represented the absolute limit of what a collapsing industrial system could deliver. And even that small number was scattered across depots, some overrun, some bombed, some simply inaccessible due to destroyed infrastructure. By war's end, ammunition meant for Sturmtigers sat in warehouses while the vehicles themselves had long since been destroyed or captured. When historians later analysed the Sturmtiger program, debates emerged. Some argued it was a waste of resources, that the Tiger tank hulls used for Sturmtigers could have been better spent producing standard Tigers or other vehicles, that the specialised ammunition production diverted materials from more useful weapons, that the entire concept was flawed from the start. Others countered that the Sturmtiger succeeded in its intended role. It demolished fortifications. It destroyed buildings. In Warsaw, it proved devastating. The problem wasn't the weapon. It was the strategic situation Germany faced by 1944. No weapon, no matter how powerful, could reverse industrial collapse and resource exhaustion. Both perspectives contain truth. The Sturmtiger was an engineering success and a strategic failure. It worked as designed. But it existed in a context where working as designed no longer mattered. Because wars are not won by individual weapons, no matter how impressive. They are won by industrial capacity, resource availability, and logistical sustainability. In 1945, the contrast between American and German ammunition production told the story of the entire war. American forces advanced with ammunition stockpiles measured in millions of rounds. German forces retreated with ammunition counted in single digits. When American ordnance officers stood in that captured Sturmtiger in Oberembt and learned it could only carry 14 rounds, they weren't just laughing at a design flaw. They were witnessing the final proof of Germany's defeat, not on the battlefield, not in a dramatic tank duel, but in the cold mathematics of production. 18 vehicles, 317 rounds. Less than 1 full load per vehicle. It wasn't engineering, it was arithmetic. And arithmetic doesn't lie. The 14 rounds became a symbol, a reminder that technology alone cannot win wars. That innovation without industrial backing is just expensive experimentation. That the most devastating weapon ever built means nothing if you can't feed it ammunition. For the American engineers who evaluated the Sturmtiger, the lesson was clear. Build good weapons, yes. But more importantly, build the infrastructure to sustain them. Stockpile ammunition. Plan logistics. Ensure supply chains remain unbroken. Because a tank with 1,000 rounds will always defeat a tank with 14, no matter how thick the armor, no matter how powerful the gun. Quantity has a quality all its own. And in World War II, America had mastered that lesson while Germany learned it too late. The Sturmtigers that survived the war sat in museums, silent monuments to ambition without resources. Tourists walk past them today, marveling at the massive rocket launcher, the thick armor, the engineering complexity, Plaques describe the specifications, the weight, the crew, the armament. But the most important number is often overlooked: 14 rounds. That was the difference between a weapon of war and a curiosity. That was the gap between Hitler's dreams and Germany's reality. That was the moment American engineers stopped being impressed and started understanding that they had already won. Not because their weapons were better, but because they could build, supply, and sustain them without limits. The laughter in Oberempt wasn't mockery. It was recognition. Recognition that Germany's war machine had finally run out of bullets. And once that happened, no amount of armor or firepower could change the outcome. The Sturmtiger fired its last rounds in April 1945. By May, the war in Europe was over. The vehicles that remained were scrapped, captured, or buried in rubble. The ammunition stockpiles were seized or destroyed. The factories that built them were dismantled or repurposed. And the lesson of the 14 rounds entered military history, not as a footnote, but as a warning. That wars are contests of production as much as battles of courage. That logistics matter more than innovation. That the greatest weapon in the world is useless without the industry to sustain it. American engineers took that lesson home. They studied it, applied it, built entire supply chains around the principle that ammunition should never run out. Decades later, when military planners designed new weapon systems, they always asked the same question: how many rounds can it carry? And more importantly, how quickly can we resupply it? Because the Sturmtiger taught them what happens when the answer is 14 rounds total, the war ends, the factories close. And history remembers not the power of the weapon, but the emptiness of its ammunition racks. In the end, the Sturmtiger wasn't defeated by the Sturmtiger, Allied tanks. The American engineers who laughed in Oberempt understood this instinctively. They had come from a nation where ammunition was so abundant it was measured by the trainload, where factories produced more shells in a week than Germany managed in a year, where supply convoys stretched across oceans without fear of running dry. The 14 rounds told them everything they needed to know. Germany had lost the industrial war long before the shooting stopped, and once that happened, no Tiger chassis, no rocket launcher, no engineering brilliance could change the outcome. The Sturmtiger became a symbol of late-war desperation, a weapon so powerful it could destroy buildings with a single shot, and so starved for ammunition it rarely got the chance. That contradiction defined Germany's final year: ambition without resources, innovation without production, weapons without bullets. The American engineers filed their reports. The captured Sturmtigers were tested, photographed, and eventually sent to museums. And the story of the 14 rounds became legend, told in engineering schools, discussed in military academies, cited in logistics courses as the perfect example of what happens when tactics ignore arithmetic. Because in war, numbers matter, production matters, ammunition matters. And 14 rounds, no matter how powerful, will always lose to unlimited supply. The Sturmtiger proved that beyond doubt, not through failure on the battlefield, but through success in the factory. America's factories. Where ammunition flowed like water. Where supply chains never broke. Where the question wasn't how many rounds can we carry, but how many rounds do you need? That question won World War II. Not heroism, not tactics, not even technology, but the ability to produce, transport, and deliver ammunition faster than the enemy could expend it. The Sturmtiger, magnificent and doomed, stands as proof: 65 tons of steel, one of the most powerful weapons ever mounted on tracks, and only 14 chances to use it. When American engineers looked at those empty ammunition racks, they didn't see a tank. They saw the entire war, compressed into a single number, 14, the number that explained everything. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.